Hi friends, welcome back to my channel You Can Love Chemistry. Today we are discussing about the Favorskii rearrangement. Favorskii rearrangement that occur in alpha haloketones. Alpha haloketones in presence of base, it is rearranged to form carboxylic acid derivatives. Okay, carboxylic acid derivatives. Intermediate in this reaction is a cyclopropanone intermediate. Okay. Let's say an example. This is alpha haloketone, cyclic ketone in presence of NaOH. This become COH. Okay, you can see here that the cyclic size of the ring is decreased, or size changed into a smaller ring after the completion of reaction. Okay, and the mechanism of this reaction is first step is the enolate formation. Okay, first step is the enolate formation, that is this is a cyclic haloketone, and in presence of base here NaOH, and one of the things that you have keep in mind that the hydrogen is abstracted by the base is away from that hydrogen, that is away from the halogen atom. Here we can see that here is the presence of one hydrogen and here is the presence of hydrogen. This hydrogen is close to adjacent to this halogen atom, and this is away from the halogen atom. So the hydrogen abstraction is takes place by this side, that is this hydrogen is abstracted other than this. Okay, so it get abstracted, and this bond is shifted to this side and this is shifted to this side, and the O minus. Okay, this is the first step, and the second step is the cyclopropanone intermediate formation. Okay, cyclopropanone intermediate formation. Here this is the enolate, and here this bond shifted to this side, and from here this bond is shifted to this side, and this bromine get eliminated, and this become and this one is the cyclopropanone intermediate. Okay, and the third step is the ring opening, that is it is attacked by the cyclopropanol ring is attacked by a hydroxide nucleophile, then this cyclopropanol ring opening takes place, that is attacked by the hydroxide nucleophile and the ring opening of cyclopropanol intermediate. Okay, that is this is the cyclopropanol. When this hydroxide nucleophile approaches and attacks this carbonyl carbon, then this bond gets shifted to this side, and this shifted lone pairs, when it coming back, that is I will that explain two step, that is this become OH and O minus. So after the hydroxide nucleophile attack the carbonyl carbon, this bond gets shifted and this become and after this lone pair again shifted back to this side, then this either this or this bond gets shifted. Here we can see that both sides there is no any substituents or anything, so the carbocation that is formed in this bond shift is same in this case. That is, if this bond is get shifted, this become here is the lone pair of electrons, and this is C double bond of OH, or if this bond is shifted to this side, this become so the both are same, that is the final product that formed in both cases are, this is the final product. It is the important points that we have to keep in mind in the Favorskii rearrangements are, first one is the ring opening take place to that side which give a stable carbanion. Okay, so please this keep in mind, this is an important point. So ring opening takes place to those sides which give a stable carbanion. Simple tricks that we can apply to identify the final product in Favorskii rearrangements are, if the starting material is only having one halogen and that is a one haloketone, then the product is a saturated acid derivative. That is done one example, that is here. the product is what? Okay, this is a saturated acid, and if it is having it is a dihaloketone, then the product is unsaturated acid derivative. Okay, that is if it having two halogens in the study material, then the final product is this one. Okay, that is an unsaturated acid derivative. And if it is having trihaloketone, then the product become unsaturated halo acid derivative. Okay, this is the important point that you keep in mind. This is a simple trick to identify the final product. Okay, another important point that we have to keep in our mind is the use of base. That is, depending on the base, the final product become different. That is, if the base is an simple hydroxides, that is hydroxide ion, base is having hydroxide ion, that is example NaH, the product is carboxylic acid. Okay, the product is a carboxylic acid, and if the base is an alkoxide, that is example NaOMe, this is an alkoxide base, then the product is an ester. Okay, the product formed is an ester. And if the base is an amine based base, that is example NaNH2, and the final product is an amide. So please keep these points also. This is also important point in this reaction. So keeping on these important points, we can easily identify the final product of Favorskii rearrangement. Consider one example, that is this is one of the example in which this hydrogen is get abstracted, and this become Me O minus. Okay, this is the enolate formation. When this comes back to this is the shift that occur, and this become methyl. Okay, this is the cyclopropanone intermediate that formed, and again the nucleophile approaches and attack to the carbonyl carbon, and this bond shifted to this side, and this become minus OH. Here comes the case of stable carbanion. Just look at this primary carbanion stability is higher, that is higher stability than secondary carbanion than tertiary carbanion. So there is just consider the two cases. This here when this bond shifted to this, and if it is shifted to this side, this become Me minus charge OH. Sorry, OH. This is a tertiary carbanion. But when this is shifted to this side, this become Me minus double bond of OH. This is primary. This is a primary carbanion. So compared to the tertiary carbanion, primary carbanion is stable, more stable. So the reaction proceeds to this side, and the final product become Me. This is also Me OH. So this is the final product. Consider another example. Bromine. Here, if the base is an alkoxide, then the product become double bond of OMe. This is an ester. And if it is an amine base, okay, if it is amine base, the product become an amide. Okay, so this is the Favorskii rearrangement. I hope you understand. If you have any doubts, please mention that in the comment box. We will see another name reaction in the next class. Okay, thank you.